is let us continue with the previous topic, that is we were discussing on your linear block codes, where the linear block code is represented by n comma k block, where n is the number of bits in the code word and k refers to the number of check bits, and you are going to have n minus k which is equal to q, which is going to represent the number of check bits in it, where k is the number of message bits. And this is how you get the check bit for a specific set of message bits, and this is how the code word is formed. You are going to have your code word or the code vector to be message bit appended with the check bits. So, this is going to be the message bit and the corresponding check bit is this, and this is going to be the polynomial which is used for generating the check bits. For example, for representing 0 1 0 as a message block, you are going to have the check bits to be 1 0 1, and you are going to append this, and this entire thing forms one code word, and this we can call it as this is going to be 6 comma 3 code vector, because there are 6 bits in the entire code vector and 3 is going to be the number of message bits, and n minus, so this is n and this is k, your q is equal to n minus k, which is also 3. So, this q is going to be your 3. Now, let us continue with the previous lecture. Now, we will see what is a parity check matrix. The parity check matrix is represented as H, and for every block code there is q cross n parity check matrix H available. So, already we have seen what is a block code, and that we have seen what is a linear and non-linear. So, here they are saying that for every block code there is going to be q cross n parity check matrix represented as H, where this parity matrix H is equal to P transpose appended with identity matrix. We have already seen what is P matrix. P is going to be the submatrix of submatrix, which is from your generator matrix. We already know what is a generator matrix. Generator matrix is identity matrix appended with the P matrix, and your H, that is going to be the parity check matrix, is P transpose appended with the identity. So, when you know what is P, you can get the P transpose value. So, this is going to be your P. P is going to be k cross q, where k is the number of message bits and q is the number of check bits. So, accordingly the size is going to be defined, and you are going to get the transpose of this, and the transpose of this is appended with the identity matrix. Now, we will see how you get that value. So, this is going to be the transpose of your P submatrix. So, all the rows has become column elements, and you just interchange the rows to the column elements, so that you can get the P transpose matrix, and this H matrix is that P transpose matrix appended with the identity matrix. So, this is going to be your P transpose and this is going to be your identity matrix. So, if for any linear block code you assume there is a G given, that is your generator matrix is given, then if you are going to find the parity matrix check matrix, you can easily find it out. For example, if P is given like this, what is P transpose? This is going to be the P transpose. P is going to be available from the generator matrix because it is I appended with P. So, take the P and write it separately. Take the transpose of it. So, just interchange the rows and the column elements. You will be getting the transpose of it. Now, you can generate a unique parity check matrix, which is your P transpose appended with the identity matrix. So, this size is going to be 3 cross 3. 3 cross 3 means automatically, and the identity matrix should also be 3 cross 3. Okay, so, this will be your 3 cross 6. Okay. Now, we will see the next coding called as Hamming code. So, Hamming codes are also a linear block codes, and it is going to be represented by n comma k. So, that is why we discuss what is generator matrix, what is parity matrix, how to find P transpose, how to get the parity check matrix. So, the importance of those topics are going to be applicable in this Hamming code. So, this is also a linear block code, and these codes should satisfy the following conditions. The first condition is the number of